So, as Chris said, GraphQL for newbies, but with a thesaurus. What is an API? Like, what do y'all think an API is?
Application programmer interface, usually HTTP based.
Yeah, yeah. What does it do?
Transfer data between one system to another.
Yeah, that's what I think. It's like anything that transfers data from one system to another. Like, perfect. And they've been around for a long time, right? Probably since computers existed. So one of the earliest like forms of APIs was SOAP. Who's worked with SOAP? Who enjoyed it? So it stands for Simple Object Access Protocol. It's like an XML-based messaging protocol. It's essentially remote procedure calls over the network. So this was like one of the earlier forms of this. People thought SOAP was hard to work with. They wanted something more lightweight, so they started just creating like these bespoke API endpoints. So, hey, I need a list of products, so I'm going to create this products list. I need to add a new user, so I'm going to create an add user endpoint. There's no convention, so like every app works differently. So then we got REST. Who here has worked with REST APIs? Like probably everybody. This is like the de facto standard pretty much right now for APIs, and REST is great. It's a vast improvement over like that bespoke API situation. Mainly because it follows like conventions. Like if you know the REST conventions, you can go to another project and very quickly like see how this thing works. It's based on the URI and like the HTTP request method. So like a get, post, or a delete, those all have things that they do. And because of that convention, there's like an ecosystem of tooling that can work with it because it behaves the same way, so the tools can treat it that way. So that's where we came from, right? So in my opinion, GraphQL is like that next generation. So it's a Facebook project. They open sourced it in 2015. It was used internally before then for a few years. It's an alternative to REST. The stated purpose from Facebook was to increase developer productivity and to minimize data transfer over the network. Those are like the two purposes.
Yeah. So you say they open sourced it. Is it like a spec they open sourced or an implementation of it?
Yeah. So next slide. But it is a specification, and they also released a reference implementation in JavaScript. So it's used hundreds of organizations, big companies now, like Facebook, obviously, but GitHub, PayPal, New York Times, plus small companies, because you don't have to be big to take advantage of this stuff. So,
what kind of open sourcing? Is it free software?
Yes, actually it is. The thing with that is, most of well, let me step back. Until 6 months ago, the situation was it was open source, but the repo was controlled by Facebook employees. They accepted pull requests and things like that, but they ultimately made the decisions of what went into it. About 6 months ago, they created a GraphQL Foundation, which is not just Facebook, it's a bunch of companies that take part of it, and they now own the spec. And so it truly is like free open source now. So one thing I want to make clear is that it's language independent. They released the JavaScript reference implementation, but it's a spec. And so like there are now libraries in all these languages and more that I couldn't fit on here. So yeah, I had to get Haskell in there. So there's like two main pieces, right? So the client. This is like, they make HTTP calls to the server, asking for some data, and they get it back, just like you would call a REST API. This is like your web apps, your native apps, like on Android, iOS. This could be like embedded devices, anything that talks HTTP can call this. And the server is just like any server that meets the spec can be a server. Typically, it responds to a single endpoint. That's one of the big differences between REST and this. It's like a single endpoint. We'll talk a little more about that. So it's data agnostic. This is another thing that tripped me up when I was first learning about this. You can use it with any data store. It's not tied to anything like that. So like SQL databases, document databases like MongoDB or Amazon DynamoDB. APIs, this is, in my experience consulting, this is where I see it being used a lot. We have like legacy APIs and they put GraphQL in front of it to sort of hide that stuff, and then that can evolve over time, and the GraphQL part stays the same. And then also microservices is another place where I really see it. Instead of having clients have to call like 15 different services, like they just call the GraphQL server that does the orchestration. And all at the same time. Just get some data from a database, some from an API. So they say it's a strongly typed declarative query language. So like, what does that mean? That's a lot of words. So let's break it down. So strongly typed, it means what it says, right? It's type safe, but it's type safe across languages, not just in C or in JavaScript or in TypeScript. So this here is like an example schema, and don't worry about the syntax, we're gonna go over this in more detail a little bit later, but I wanted to show this. So like the schema is like how you define your inputs, your outputs, your types, and things like that. These are like, that's an integer, that's a string. These are like what are called object types, which we'll talk about more later, but you can see how they can also refer to each other. So you have a type called post, which has an author, which is itself a custom type. Here's another one. Author has an array. We'll talk about that syntax. That's an array of posts or a list. So declarative query language, what do we mean by that? So you ask the server for the data that you want in the shape that you want it, and it gives it to you in exactly that shape. All right, so like I want to spend a good bit of time here because I feel like people adopt new technologies because they're fun or they're cool, but in my mind, like you need to know what problems it solves, or else like you might be adopting something that doesn't solve the problems you have. So like those two purposes we talked about earlier, like minimizing data transfer, developer productivity. If you don't have those problems in your application, like it doesn't make sense to use GraphQL. But in many cases, it will help. So like, here's some sample code from our app. I apologize, Chris, it's in JavaScript. So
I didn't write it, you wrote it.
So let's say we need a list of Star Wars characters and we want the names of all the films that they're in. So like, how would we do that? So first, let's call this REST API to get a list of the characters, right? Then we're gonna loop over those of each film for each character. Then we're gonna call, the film REST endpoint to get that. And then we're gonna cache it because we don't wanna do this when we don't have to. But like, look at the network waterfall that occurs here. We make the first call to the people endpoint there. We can't even make any more until after that because we don't know what movies they're in. Right, so then we get all these additional calls, 7 seconds just to get the data we needed for that simple view. Right? Why is this? It's because the model of REST is a resource-based model. So you get a person, you get a film. Those are like independent things. They have relationships to each other. But it's like a normalized database table. That's kind of how I think about it. So clients that if they need to combine this, which almost every view does, has to do that stitching together manually. So more network, more CPU, bad. So here's the request to get the same data in GraphQL. Single request, we get exactly what we need. Don't worry about the syntax too much. So overfetching. Let's go back to that same example, but let's say we don't care about the films now. We just need, all the data that we need is in that one endpoint. We don't have to loop and all that. Problem solved. Still a problem, right? REST gives us all this information, but I just wanted like the name and their height. That's all I wanted. Right? Big waste. If you're on a mobile network, if you're on 3G, that's going to drive you nuts. So here's how GraphQL would solve that. You get just the data that you asked for. No wasted bytes. So documentation. This is another problem with every API I've ever worked with. You get this, right? Who here has ever experienced this?
All the time.
You do that?
I've even inflicted it.
So let's say you're lucky and you do have documentation. Like, this is beautiful. I would love this. I never get this. But it requires developers to update it, right? It's a manual process. Even the best teams I've ever worked with don't get it right. You forget to update it, or it becomes outdated, it's wrong, and then you get like this. So GraphQL, how does it kind of solve this? It has something called the introspection system. So it's essentially like a built-in way for clients to like query the abilities of that server. That's how you can, like, it'll reveal all its types, all its queries, mutations, and things like that. So you query it like this, and then you get back something like this. You're not going to ever use this in your application, but this is what you get from the introspection system. The reason this matters, why do you think this matters? If you're not going to use it.
Because it implicitly documents the API.
That's one good reason, yep.
You need a client that will generate documentation from this.
Right? Tooling, right? So it allows awesome tooling to be made. This is an example of a tool called GraphQL Playground. It comes with like JavaScript version of Express Server. No one wrote this documentation. It's just reading the types of my application. I can click through it. I can see the comments. I can see what the input types are, the return values, that kind of thing. So there's like 3 main operations you can perform from the client. All, like I said earlier, from a single endpoint. So queries, mutations, subscriptions. So we'll go into them in a little bit more detail here. So queries, like they sound, is a way to request data from the API. This is an example of a single query with no parameters or anything like that. This is just like saying, give me all persons, and these are the fields that I want. So this is the name of the query that's going to be defined in our schema. These are like the fields we care about. This whole thing is a string, by the way. It looks like it's like JSON or an object or something. It's not, it's a string, literally. So this works too. White space doesn't matter. And this is what you would get back from that. And like before, we only got the data that we asked for. Even in the sort of like nested types. So like, we know a person has a name, but they also have a home world, which has a name. You know, and this could go infinitely deep. That's why it's called GraphQL. Like, you literally could keep going and going and going. Oh yeah, so that. Right there. Except, I didn't order them right, so that I should have made it so the arrows were straight across. I ran out of time. So up until now, we've been using the shorthand syntax. So what we just did here, this is like the shorthand syntax for a query. So it leaves out 2 things: the operation name and the operation type. So operation type can be query, mutation, subscription. Operation name is whatever you want to call it. This can be unique to your client. It's anything. So we want this query to be dynamic. We don't want to hard code IDs in our code. We don't want to have to do string manipulation to insert an ID in the string and all that kind of thing. So this is why you can use variables. This is how you define like the required variables for that query on the client. And then this is how you actually pass that variable like to the server. When you actually make the request to the server, you see how the query is this string here? The variables are sent like as a separate field. They're not like inserted into the string. So here's your response. Same thing that we saw before, but this is just like a single entity instead of an array. So here's a mutation syntax. Exactly the same. The only thing different is it says mutation at the front of it. By convention, mutations, if your server's going to change some data, you should use a mutation. It's not actually enforced. Just like in REST, it's really not enforced. But like, don't change data in a query, please. So in a mutation also, you can request what data you want back from it. So like, I am updating this person's hair color, and I'm going to request back the ID, the name, and the hair color, and I want to see the new value and update my web page or something. But you could also request a whole bunch more. That's not defined on the server. That's whatever you want. You ask for it, you can get it back.
Do the client libraries try to use the right HTTP verb based on what you're doing, mutation?
It only uses one. Post. Everything's posted.
Okay.
You can configure it to be gets also, or both. However, it's one of the criticisms of GraphQL is that it doesn't use native HTTP handling and caching and that kind of thing. So a subscription is a way to like query data on the server, but instead of like getting a one-time response, you're gonna get this data like real time over a website. So like, let's say your server is handling comments. You can actually push over a WebSocket to your client every time a comment is added. And that's what subscriptions are used for. I haven't used these in a real app. Have you? Yeah? That's cool, huh?
It works really, really well. Is it like, that's part of a spec? Is that handled by all the different libraries?
It is part of the spec. So a library that calls itself GraphQL has to handle it.
Cool.
They're just like bundles of the WebSocket.
Yeah, so like your client establishes, there's a different port that it listens on, I believe. Or a different endpoint. I'm not totally sure on the semantics of it, but essentially you open that WebSocket connection and it pushes.
It's a different verb
It's a different verb.
to negotiate a WebSocket.
Okay. Thank you. So fragments. These allow you to like construct a set of fields and include them in queries when you need them. It helps to avoid repetition, especially like if you have a bunch of queries across your app, but like you always want the same set of detail for a person. You can create a person fragment. Notice how it has to be like on a specific type. So it knows essentially like what type this applies to. And then this is how you use it. And notice that it's under the Starship type. Actually, the Starship above there on line 2 is the name of the query. It returns a Starship type. You can't see that here, but. So people think that you need to use a framework to use this. Like you have to use Apollo or whatever. You don't. It's just like an HTTP request, just like you would call a REST API. So like I wrote like a simple web page that calls a GraphQL server into place and results. So like here we go. We set up a button with an on click where it calls this fetch characters function, and then there's just like a list, an empty list there for our results. So here's the GraphQL request. There's our query on line 11. We use fetch, like the native fetch in the browser, to call that. And then we just loop over that data and create these elements and append them to the DOM like it's 1999. But this is a bare bones web application using GraphQL, like 27 lines of code. You don't need a framework. It's super lightweight. But use a client. There are a few available. The most popular by far is called Apollo. So the main benefit from using a client, and they almost all do this, is you get caching, like local caching and batching for free. So let's say you had 5 different components that all needed a user. Each one would have that GraphQL query, and it says, "Hey, give me user 1, 2, 3." These frameworks or these clients would like know that and make one request for that data. And then if you navigate to another page, it already has that cache. It doesn't even make the call. So here's a simple React component that uses my preferred client library. It's called GraphQL. Happens to be made at Formidable Labs. So like, here's the only GraphQL piece of this. There's our query, and then there's this React hook that comes with Oracle called useQuery. And then you get this result here, the first element of that array. That's what that destructuring is. And then here, like it has, if there's an error state or if it's fetching, or otherwise you have the data. And it's like, that's it. Like really simple. Especially with React hooks. If you're working in an older version of React that doesn't support hooks, it also has like higher order components, render profs, I'm sorry. If you know what that is, you know what I mean.
I should really upgrade.
The project I'm on right now is like 16.2. So that's the URL for it. It's even got a cool logo.
That's the most important part of it. Who made the logo?
We have some graphic designers that work for us. So all right, last piece, server code. Oh, we're going fast. I'm going really fast. Too fast? Am I going too fast?
Just means we get to drink more.
All right. Does anyone have any questions what I covered so far?
Yeah, answer my question. How strict are the types?
Yeah, it's coming. I mean, I don't know how to answer that. Strict? It has to be an integer if it's called integer.
Really, how there's a whole bunch of different definitions of it.
Yeah, I got you. Okay, so here are and I'm not going to answer it. So here are there's like three big building blocks on the server. There's the schema, this is like the granddaddy, that's the big thing. And then resolvers, this is what actually like returns the data. And then context, I'll cover with resolvers because it's sort of related. So the schema, like I said, is the core of everything. This is where you define all the operations and types for your application. Just like queries, it's a string. You see how it's syntax highlighted here? That's because like all the major IDEs know that this is GraphQL and highlight it for you and everything. So the fact that it's a string doesn't make it hard to work with or anything like that. So these types here, query and mutation, like these are special because, and I could have also put subscription here. These are like the entry points to your application. So a client can't say, ask for book, right? It has to ask for one of these queries that you define. And like a real application is going to have a lot of these. So those are our like special types, right? And then here's like our application types. And again, you see how they can refer to each other? So that query syntax, we'll go over it in a bit, but just, it's kind of evident. Like the all books query returns a list of books, right? Get author requires an ID as its argument, and it returns an author type.
So like, I guess the easiest thing to describe is JSON has a particular encoding. A number in JSON is formatted in a particular way. There's an exact regex you can use to find a number, and it is defined as being represented as a 64-bit double precision floating point number IEEE 754, right? It's part of the spec.
Yeah, so that would be represented, all that would be represented as a float, essentially. There's no doubles, there's no anything like that. You got integers and floats. Those are your two options for a number. How those actually get converted to like the type in your language, I don't know. Like JavaScript doesn't have types, so that becomes whatever you want it to be. Like in TypeScript though, that would come back as a number. It would both come back as numbers because floats and ints are both a number.
Well, and then your resolver, you can check the incoming value and do some sort of like type validation, I guess. And then the GraphQL spec says just return null if you have an error for that node. So you just return null, and then your client would have to go, oh, I'm stupid. And then the IEEE
Yep.
other hint.
So at the bang on the end, I make them required. So everything's null, or null is allowed by default. I really wish there were more built-in scalars.
Yeah.
Because every application needs like a date, an email, like.
Just use Julian dates and put them in the float.
Yeah, but you could, the way that the custom scalars work, you can do the data conversion for it. Anyway, whatever.
Don't do that.
All right, object types. If you need anything more complex than those scalars, which you will, this is what you use. It's made up of scalars and other object types. So like this is an object type called hull. You know, it has some scalars. It also has an object type, and it has an enum. I don't mention enums anywhere, but that's how they work. I mean, just like in every language. And the value that comes to the client is the actual string. It's not like a number-based enum, like TypeScript does, I think. Yeah. In most situations, like this is all you need: scalars and object types. Like that's 99% of what I do. So field parameters. This is cool. So remember how those queries could accept parameters, like the ID for the user, whatever. Individual fields and types can also accept parameters as if they were a query. So like this is an example of a required sort field on books and an optional sort field on hobbies. So if the client was making this query, like they would have to pass a sort to books. And notice this is not a parameter in the query. This is like down in the fields you're requesting. But for hobbies, you know, you could do it either way.
And you have both.
You can have both, but you'd have to alias one of them. This is not valid without aliasing it. But yeah, you can, in fact, for performance reasons, you can call multiple queries in one HTTP call too. So you wrap the type in these brackets to make it a list. This is an example of strings, but it could be an object type too, so this could be like author or boat or whatever. There's 4 possible ways you can return like list data, if you think about it, in any language. Like, we're assuming strings here for this example. So an array of strings, and they're all there. Or an array of strings, but some of them are null. Or like you just return nothing. Or you return an empty list. So depending on which of that syntax you use, some of these are allowed, some of these aren't. So like, this means it has to be a string, but it's not required. And you can also return null because my array is not required. So all of these are okay if you use that. Don't use that. So this one is better. If you return something, so you don't have to return anything because the array is not required. However, if you do return something, it has to be a string, like this null in the middle there, which is the worst. It's not allowed. This is saying the array is actually, oops. Oh, damn. Gotta watch this again. So this means the array is required, but you can't have nulls because string is not required, right? So you can't return like a null value, but you can return a null. And then my favorite, both. This is like to be the non-insane way to do this. If you're going to return an array, make sure they're all strings. Or if there's no value, like return an empty array. Sometimes this is not appropriate because null is an actual different value than an empty array. So you'll use this one and the second one most, I think. So queries and mutations, we sort of already talked about this. They work just like object types, but they're treated special because they're the entry points into the graph. So this query has no parameters. These 2 have parameters, and then this is a mutation that accepts 2 parameters. So I'm going to go quickly over some stuff we don't have time for. We probably did have time, but we'll say we didn't. We'll tell my wife. All right. So input types. See how on line 5 it says input instead of type? Looks exactly like other types, right? Except that's input in front of it. This is the only type you can use as a parameter to a query. It's actually pretty complicated when you dig into why they made it that way, because it looks like you should be able to use a type, right? But it has to do with how types can refer to other types in a circular manner, but inputs can't. I learned that making this presentation. So comments, this is how you add a comment. It's like a string literal. And if you remember that GraphQL playground we saw, these will actually show up in the documentation on those fields. You can put comments like above a type and it'll apply to that whole type, or in this case, it's just an individual field. So interfaces, similar to like this concept in other languages, you define an interface and then other types can implement it. There is no extends. Like you can't have like a base type and then other types extend those. I want that, but it's not there right now. So if you implement both, you have to implement both of those fields, type into your build, but you can also implement anything else. Now notice the query down here, the type that it returns is, it actually returns the interface, not Bayboat or not Canoe. So in the resolvers, you have to treat that especially. You actually have to tell GraphQL, I'm returning this data and this is the type that it is. We won't go into that. Unions, it works like every other union, right? Same thing in your resolvers, you're gonna have to tell GraphQL what type it is. Common for search results like this, like you might get a bunch of different types of search results. So, custom scalars. If you need a date in your application for some reason, you could create a scalar called date. Essentially, this is how it would work. You put it in your schema there, and then in your resolver map, which we'll talk about in a second, there's this like these certain functions you have to provide, and then your clients can use it. So we just talked about schema, so let's talk about resolvers and context. So a resolver is not a complex thing. It's just a function that returns something. That's it. So the GraphQL server calls these resolvers like for everything. A query, a mutation, a type, an interface, an individual field, every one of those can have a resolver. Every one of them does have a resolver. You might not see it, which I'll talk about. So the way these resolvers are called is what makes GraphQL unique and powerful. So like, here's like a simple schema here. And let's say this is the client query that we made. We're calling all authors and on the ID and the full name. So what does it do? It sort of walks up the tree. So first it's going to call the resolver for all authors, because that's the query we requested, right? Now it's going to see that query returns an author type. So it's going to go to the author type resolver. And then it's going to see, oh, they're requesting ID and full name. So now it's going to go to those individual field resolvers to get data. Seems like a lot of work for like, you don't have to implement any of these except for like the very first one. If an object that you return, well, one thing I should say, as you walk up the tree, any data you return, it augments the previous data or replaces it, depending on what you do with it. So like if all authors returned name of Stephen, and then up here in the field resolver, you return Chris, like it would be Chris. If you return an object from any of these, and a resolver doesn't exist, it just looks for a field name, that field name on that object. So if you return an object from all authors resolver, and it has a field called first name, it's going to use that. That's called like the default resolver, and very common on, especially like on field types. Unless you need to like do some special formatting or something on them, there's no reason you have to implement it. Like a common one I see though is like your database has first name and last name, but you want to give your clients like a full name where all that logic is on the server. you can put that in like a full name field resolver. So resolver map. This is like how you provide your functions to the GraphQL server. You give it an object, right, and it has some high-level keys. Query, it could have mutation, and then for each type that you have, you also have like another object, and then nested within there are the fields. And then when you're actually implementing your starting your server, this is like not real code, but like you pass it your schema and your resolvers, and that's all it needs to start. So here's our function signature. Third parameter, context. So, like I said, this is an object that's shared among all the resolvers of a specific execution. So it's newly created on every call. That's important because you will often store things like user information in it, so that all your resolvers have the user. It can be looked up once. It's useful for keeping data like this, like a database connection, an auth token, like your data models is something that I use this pattern a lot. So like here you can see this resolver, instead of like importing like database directly like as a module, it's actually pulling it out of context now. Like doesn't look like a big difference, but why do you think that like matters?
That's cool.
So dependency injection, right? When you're testing these things, like you don't have to mock anything. You can provide whatever you want in context, especially for testing. So evolving your system. So remember, GraphQL is data agnostic. Your resolvers can fetch data from anywhere, any type of data source, whatever. So in my opinion, it's a great technology for like evolving your systems. You like put it as like, it's like your front man, and then everything behind it can change over time as long as like Steven Tyler is still singing. Like it doesn't matter who's behind it. It's kind of like that. So like, especially like with microservices, like those change a lot. You don't want your client, like especially like an iOS client that requires Apple to approve it for your people to even get it. Like they might never approve it, and they've got like a client that's going to crash when you change your server. So you can put it in front of that and sort of protect from that kind of evolution. So this is the last slide. So learn more. This book is great. I recommend it to everyone that wants to learn more. It's a pretty easy read. You can like read it in a week. The official documentation is actually really good. And then there's this site, I think Apollo did it, but it's called How to GraphQL, and it's like step-by-step tutorials where you actually like will write some code. But it walks you through it like in a very like deliberate manner. And so you'll learn about like basic GraphQL stuff, but you can also say, okay, now I want to learn how to use Urkel, or I want to learn how to use Apollo. That site like has tutorials for all that stuff. Questions?
Yeah. You had experience building RESTful APIs before this, right? Mm-hmm. In terms of getting the backend set up, what was the main differences between building a RESTful API versus creating the resolvers for import?
That's a great question. It's much more complicated to set up the backend of a GraphQL server. If you want it to be performant, you could implement it just like REST does, and you could just have a query that does those CRUD operations, right? And then you just return the full object. And you still get the benefit of returning just the fields that the client asks for, even though maybe you request them all from your database. But if you want to like get fancy with it, where like you inspect what nested thing was asked for, like for example, in that authors thing, let's say, it's a bad example. Let's say we had like actors, and then they each were in a list of movies. Well, let's say like five of these actors were all in the same movie. It's going to call that resolver like 5 times. It's going to be looking at the same data. And that's like the N+1 problem. And there actually is a way to solve it, and it's not that complicated. There's a library called Data Loader that will essentially like batch that stuff for you. But it's, in my opinion, the server side is more complex. The client side is 1,000 times easier.
Gotcha.
So it's definitely more of a benefit on the
There's a
client side.
payoff, but there's a little bit of a.
It's not, and it's not like a silver bullet either. Like
Gotcha.
if you don't have the problems that it solves, don't pay the cost.
Well, I have a similar question. If you were to compare doing REST to GraphQL on the back end, is it a 2 times, 3 times, 5 times, 10 times more complicated as far as time to build it?
Would it be like a new application?
Yeah.
I would just start with GraphQL, and it won't be any more complex. The complexity comes when you're like trying to replace a system that works a certain way, and like shoehorning it into like the GraphQL graph pattern, because that's not how REST works. A pattern that I see a lot is we already have REST APIs, or not even REST, just like APIs, and they're hard to work with. They're like 10 years old. No one knows how they even work anymore. So like we put GraphQL in front of those. GraphQL doesn't look up anything in a database. All it does is make another API call. That might seem like it's slow, but they're usually like in the same data center, same network. It's really fast. And yeah.
I also want to point out one of the benefits of GraphQL that I've seen is maintenance. You know, you can mark certain fields as deprecated, like you're saying. You can swap out the stuff in the back end. So spin up cost is just one parameter to really to score this guy on, right?
Yeah.
I mean, you may have some more costs up front, but in the long run, you get all that flexibility.
Yeah, another cool tooling thing I didn't mention is you can put a layer in front of your server, and it will like tell you which fields your clients are actually using, and how many times they're using it, how long that field takes. So you can like say, oh, this is slow. Let me figure out why, optimize it. But that comes like for free. Like with REST, you have to like manually do that. Like start logging when a field was requested or something like that. Like you get all that for free.
Well, I can say that I've thought about doing something like this before, but your explanation tonight was easier for me to get the picture, and I don't think I would be afraid. I've been afraid of trying to do the back end part.
Yeah.
Oh my God.
It doesn't have to be, I probably scared you. It doesn't have to be complicated. What gets complicated is when you worry about performance. But like, if
But
you're
you can
REST,
start out dumb and then
Yeah.
optimize later.
exactly, because you're not going to change your schema. You're just going to change how that data all gets provided.
Yeah.
And like, if you just did it like you did your REST API, your REST API is probably slow too.
Yeah.
Because you got to call it 5 times.
Exactly.
So.
And I'm good at starting out dumb.
So one of the things that was emphasized early on in the GraphQL spec that was that the transport layer wasn't actually defined.
It's not, still not, but everyone uses
No, but
HTTP.
that's kind of like a good thing. How good are the clients at being able to like swap out the transport layer if you wanted to like change the protocols communicating over instead of JSON, something else structured?
I honestly don't know because everything I've ever used has
Okay.
been on HTTP. I've never seen it like over,
Yeah.
I don't know, like you can do it binary, you can even do binary. I
Yeah,
guess.
that's what I'm saying.
Yeah.
You grab some other,
I imagine that's going to come as this gets more adoption.
or I mean, just go straight WebSocket instead of even opening up an HTTP connection.
Yeah, there's no reason you couldn't use a WebSocket to make queries. Just keep that connection open, it will be faster.
Give you an idea.
That is a good
And you
idea.
can use message tags.
Yeah.
Like the big thing is if you're dealing with a bunch of floats, JSON's gonna kill you. It's like if you got a mapping application, you can't just send JSON down the thing. You
Yeah,
have 50 megabytes of
and like
floats.
games, things like that really need that.
Is there server-side tooling to just throw it in front of like a relational database? or-
Yes. There's the most popular one is called Prisma. Is that what you said, Prisma?
No, but I'm just saying, there's good, if your language that you're working with has a good GraphQL library, a lot of times there'll be a connector into any kind of ORM or database system
Yeah.
you're using, and you can actually just like hook into your models pretty quickly.
Yeah, like Prisma, literally, you give it your database and like you don't do anything. You don't write resolvers, you don't write schema. It's
There's
pretty cool.
another one called Coursera.
Yeah. That's the newer one. I think that one's better.
It's really nice. I
Yeah.
did play with it a little bit, but it was
What's it
really
called?
cool. Coursera.
Can you type it out so everyone can know how to spell that?
Hasura and Hasura.
Yeah.
I can put it in Slack.
Okay.
Yes. Any other questions?
I've got a hard one.
I don't know.
How would you, for like a mutation, how would you handle sending like an image or some sort of data, some sort of binary?
Yeah. Notice there was no like binary data type.
Like,
That's what we do. We send it to S3 and then send the URL.
Honestly, that's easier than the right way to do it.
Yeah.
Like Urkel just added file upload support and
Really?
yeah.
And what languages for the client though?
It's written in Reason ML and it outputs JavaScript, TypeScript, what's the other one? OCaml? I don't know.
I was worried about iOS because that's where we hit it. iOS needed to upload images.
Yeah,
Right.
I'm not sure. All it is a multi-port form upload, but it's like built into the
Yeah,
server.
no, that's great though.
But yeah, that's, I would say, an unsolved problem. A couple of like downsides I didn't really mention, but like caching, right? So a REST API, if you call like get person/to, without your application doing anything, like the network layer, your routers and all that kind of thing can cache that based on the headers that you return. Well, none of that comes built in to GraphQL. So that's like there are people working on it, but I would not say like a solved problem.
Does that really matter so much anymore with everyone going to SSL, HTTPS?
It can matter because you can cache behind the,
Well, you can cache at the endpoint
Yeah.
when you do the encryption.
so like
but-
your application is cached there, so it never actually hits like your database and that kind of thing. I will say though, like the times that would have made my application faster, I can't think of any because almost always like everything's like based on what user is logged in. Like I can't assume anything at the network level.
Those client libraries do a lot of that caching for you, and they
Yeah.
do a good job.
They cache on the client side.
Right.
Yeah.
Yeah.
So your server still has to handle a lot of
The
requests.
data loader.
Yeah.
Kind of.
I would say that it's not an overblown fear, but it is an issue.
What, can you talk about the subscription? How does that work on the client side?
Yeah, so in that case, you'd want to use one of the libraries, but like we saw that use query react to it. There's a use subscription. You pass it like the query, and you're going to get new values as they come in.
And
You don't have to like manually set up the website.
So it's gonna open up the WebSocket and do all of that
Yes.
jazz for you?
Yeah, you could do that manually, but nobody does that.
Exactly. All right, so, but when you're talking to that server, suppose you're using something like Prisma and you wanted to do that, how does the server part construct to know, oh, this is a WebSocket I'm gonna open to do?
Yeah, so Prisma knows how to handle that.
Oh, cool.
And based in, I haven't used Prisma much, I know it exists, but I'm almost positive it handles that for you. And these things are interoperable, so like if you use Prisma on the server, you can use a totally different client.
Right.
They don't have to, it's a spec, so they all talk to each other. You could load balance them.
I mean, because at some point, right, you're grabbing a bunch of data from some endpoint.
Yeah.
You got that across 50 computers, but all the people who decided to stay on the subscription are on one computer. What do you migrate them? Does it
Yeah,
enable that?
You have to
A
just
problem
disconnect
with
people.
websites behind load balancers.
Yeah.
It just exists. So if you're gonna have
Yeah.
containers that die and come back, you're gonna stack all your WebSockets on one container.
There's some libraries, like when I was at DealerInspire, the chat product I worked on used WebSockets, and we used a library called Pusher, and it did that renegotiation. Like if it lost, it would automatically connect over a different socket, and like the client didn't have to handle it.
Okay.
So that's, I guess that's how it works. I don't really know.
Some little things that
I mean, sure.
If you're doing like authentication and stuff like that, are you leveraging the context for that?
Yes.
Okay.
So when the server is created, like when a request comes in, first thing you do is like create that context object. That's where I'll like pull the token out of the header, do my user lookup, and store it in context, because that's unique per request.
Yeah.
If it wasn't, that would be dangerous.
Right.
Yeah.
Cool.
One more question. Anybody else? No? Great.
All right.
Get off.
And I'm gonna be at, where are we going?
We're going to Legends?
Yeah, so if you have a question, I'll be there too.
Which legends?
The close one.
What's the close one?
The one that's 10 steps down the street.
The one by.
Follow the crowd.
All right, thank you, Stephen.
So you can tell your bosses now that you're GraphQL experts and you deserve a raise.
I don't know what managers are.